Okay, thanks, Benjamin. Welcome back, everybody. As Benjamin said, my name is Dan Gross. I work at the Samsung Strategy and Innovation Center right here in San Jose, so thanks for coming to visit me. We're actually just up the road in North San Jose, so it was a little trek down here, but not too bad. My main focus is as part of the ecosystem team in looking at IoT and specifically now the ARTIK platform, which we just introduced in 2015 and started shipping products around that last year. So starting in, so I think everybody here recognizes that IoT is everywhere. I think to the average consumer, IoT is smart home and IoT devices that you can buy at stores and things like that. But as Benjamin was alluding to earlier, IoT is really everywhere and hidden in some cases. You don't see them immediately, but there's infrastructure that is rolling out and already rolled out that can be considered IoT. Everything from smart buildings to things like fire detection, earthquake detection, asset management, as was discussed earlier, doing tracking and all of that sort of thing. So really IoT is becoming clear that it's here to stay and it's continuing to grow. And much of the systems that you'll be seeing in IoT aren't simply a Nest or an Amazon Echo. So as it turns out, the architecture for IoT is pretty common. Of all those systems you saw on the earlier slide, really a lot of them have a similar architecture that they use for the solution. And I call it emergent because I don't think anyone sat down and said, okay, this is the architecture that we're going to be using for IoT. I don't think that happened. I think really what happened is the architecture developed out of a need. And what was happening was you had embedded devices that needed to transfer data up to data centers. And so this should look semi-familiar. We have clouds really at the high level here, which is managing data and processes. You have some devices, some edge devices down below that can connect directly to the cloud if they're Wi-Fi enabled or if they want to send data themselves. There's no problem with that. But in many cases, you'll have constrained devices in these edge nodes, and those constrained devices may be reliant on gateways if they don't have Wi-Fi. So say they're doing Zigbee mesh network, or they're only Bluetooth enabled, or they're just so very low power that they require simple on-off updates to gateways. You can have kind of a variety of different types of edge devices. They're not all constrained, but many of them would be constrained. Then in the middle, of course, you have gateways, and these can be both proxies as well as have their own intelligence. So some of these gateways might be filtering mechanisms or have rules engines or that sort of thing where, you may see data coming from, say, a health monitoring edge device that is sending, heart rate information every 10 milliseconds. Now, does all of that need to go up to the cloud? Probably not. Maybe in that case you have an intelligent gateway that's filtering that data and really just looking for anomalies. And then those anomalies can be sent to the cloud for further processing, for notifications, for various things. One other aspect, I think, to IoT that's somewhat overlooked in some cases is mobile apps. I think mobile apps are a vehicle that's used in the architecture for IoT. Oftentimes it's how we interact with our edge devices, cloud data, or gateways. When we do things like onboarding, when we have to pair with Bluetooth, that sort of thing. So, so I'm adding it here to this, this sort of higher level overview. So looking at this architecture, it looks kind of familiar, right? We've saw in the past couple of presentations how the Eclipse Foundation's IoT working group really has defined these stacks around the major components of the architecture for IoT. Not going into all of the details of these stacks, but you can see that they're grouped into constrained devices, gateways, and an IoT cloud platform. Very similar to how we've observed the emergent architecture for IoT. So all of that's very interesting, and this is stuff that we recognized and observed at Samsung. So what does Samsung have to do with any of this? Well, so Samsung has some experience building connected products. Samsung ships roughly nearly 2 million products per day, and we ship televisions, smartphones, refrigerators, VR devices, et cetera, et cetera. And by 2020, Samsung hopes to have almost all of their products connected. So Samsung is very invested into IoT, and you know, you'll be seeing that in the coming years, that many of the products that Samsung produces will be IoT enabled. Now, Samsung, although we ship a lot of products, we're not going to be building every product. As a matter of fact, Samsung has a very large component portfolio as well. So you'll see many of these components from Samsung's component portfolio in other products. So Samsung sells a lot of DRAM, NAND, SSDs, of course application processors such as the Exynos line. You'll see LEDs, displays, all of these things that may end up not being in a Samsung product but another product. So that's all very interesting. What does that mean? Well, so this is the basis that we started Samsung ARTIK, which is an IoT platform that the goal is to deliver a secure and intelligent, interoperable platform for products and services that's open and partner friendly. So let's look a little bit into what the ARTIK platform is, and then I'll talk a little bit about how Samsung is leveraging open source within this context. So yeah, indulge me in diving into some of the marketing material here, but I hope it explains the platform a little better. So first off is modules. So ARTIK starts off as hardware modules, and these are basically the processor, memory, the radios, and security that make up the brains of any device. And so we have really right now 4 families of modules, starting with the ARTIK 0 on up to the ARTIK 10. The ARTIK 0 is really what you would consider useful for a constrained device. These are MCUs that usually are low power and run a real-time operating system. From the ARTIK 5 on up through the ARTIK 10, these are Linux-based systems, and I'll jump in a little bit more on some of the details for each of these families. I won't bore you too much and get to the open source part. First off, as I mentioned, the ARTIK 0 line, we have 2 right now, the ARTIK 020 and the ARTIK 030, and the 020 is Bluetooth based, and it's a Cortex M4, and the 030 is Zigbee or thread based, which is the 030. And each of these can be embedded into devices such as lights, smoke detectors, locks, those kinds of things. That's the intent there. As we move up the family chain, the ARTIK 5 is kind of our first level Linux system, which is a dual core A7, has 512 mega RAM, and so forth, 4 gig of eMMC. This is, similar to a Raspberry Pi, if you will, the guts of it, and could be used in things like security cameras or more intelligent type devices, or gateways. And so this is really where we start to see the usefulness for gateways. Real quickly now, just moving up through the line, we also have now an ARTIK 7, which was introduced not too long ago. A little bit more performant and capable than the ARTIK 5 line. And we're starting to see facial recognition, robotics, things like that come into play there. And then finally, we have the ARTIK 10, and we have a line of modules in that family that really tie into our flagship processors for our smartphones. So you'll see, for example, this is, I think, pictured as the ARTIK 1020, and that's based on the Samsung S5 smartphone Exynos chip. So again, more memory, faster processor, and really for higher end type of applications in IoT, such as drones, VR, smart factories, those types of things. Okay, so that's the hardware side of ARTIK. Something that is kind of important is, how do you use the hardware once you've got it? Because IoT is really more about the solution than just the hardware. So something that we've brought together on the hardware platform is the ARTIK SDK. And this has been a work in progress and is still somewhat of a work in progress, but we do have some versions out now, and this ships with our hardware products. And if you notice, this is really kind of a consolidated framework around IoT. So at the very low level, you'll see things like GPIO, I2C, serial, all these things that interface directly with the hardware. As you move up the stack, you'll see some networking protocols, such as Zigbee, Wi-Fi, Bluetooth. And then you'll see communication protocols, such as MQTT, lightweight M2M. And then finally, you'll see higher level packages in the API for things like media. So for example, if you want to play a sound or capture video or do some of those types of things, then there's functions available in the SDK to do those things. So you can just say, ARTIK.play sound, and you play a sound. We also have a package for cloud. So this allows you to integrate into the next thing that I'm going to talk about, which is ARTIK Cloud. So we support MQTT, CoAP, WebSockets, REST, all those types of things to interface with the cloud. There's also a library around security. And then another library that we're developing around sensors. And so if you have commonly used sensors, such as temperature sensors or other kinds of things, even actuators, we can roll that into the sensor library and make that available to your application. So really the point here is try to bring together a full SDK that allows you to write your application just using one set of API calls. And so we hope that makes the productivity around developing IoT apps much higher. So as I mentioned, the other component of ARTIK is the ARTIK Cloud. And the idea here is that what ARTIK Cloud really stands on is trying to make connections and not silos. And ARTIK Cloud has spent a long time building out interfaces with other platforms and doing integrations with other ecosystems, really. And the idea is that we don't have one particular set of siloed apps, but that we work with all kinds of brands. If you see here, we have interfaces into Nest, into the Philips Hue, even web services such as Twitter and that sort of thing. And so some of the key points with ARTIK Cloud really are, connect any device to any cloud, and use ARTIK Cloud really as a bridge for your ARTIK modules to any of the services out there. We have a convention known as manifests, and so manifests really allow you to define data types that then can be useful for doing things like introspection and normalizing data that gets transferred back and forth. There's a rules engine in ARTIK Cloud which allows you to have interactions with devices or even other clouds. And then there is a mechanism for updating and managing devices to a certain degree within ARTIK Cloud using LWM2M. Considering the Hawkbit presentation and demo, I'd love to see Hawkbit integrated into this as well. So as I mentioned, 950 plus devices and clouds that have already been integrated, and so really offers kind of a bridge between the ARTIK modules and any devices that you build with ARTIK modules to the cloud and any other sort of federation of clouds. So just to summarize, the point of the ARTIK platform is that it's open, that we can use ARTIK modules to interface with third-party hardware, third-party clouds. The SDK can be used to interface with ARTIK Cloud or write local applications to use the hardware effectively. So how is all this done? Is this just all magic that we have tons of engineers at Samsung and we figured all this out all proprietary? No, it's not. As a matter of fact, what's behind all of this is leveraging open source. And so I started to put together a little list of all of the different open source projects that we leverage with the ARTIK platform. I don't think this is even complete. But you can see that there's quite a number of open source projects that Samsung's leveraging for ARTIK. And in particular, there's a number of them that are basically sponsored by the IoT working group at the Eclipse Foundation. I've circled those in red. I think the stack concept that the IoT working group has fits very well with Samsung ARTIK platform, and I think we're working towards actually aligning to those stacks. Right now, it's project by project, but there's a lot of work underway to expand the platform even more. I can talk a little bit about what some of these projects are if I have a little time. So on the OS level, right now we ship with Fedora as our OS on the ARTIK 5, 7, and 10, and we also support Ubuntu and also Tizen because we're Samsung. So most of our televisions and watches and refrigerators actually run Tizen, and so ARTIK is no different. We've also worked with Resin on the Resin OS and making that compatible, and also the Yocto project. As far as runtimes, all the popular runtimes from JavaScript to Java all come bundled on the ARTIK platform when it ships. And then as far as comms, this is really where we rely heavily on the Eclipse Foundation IoT Working Group with projects like Paho, Wakaama, Californium, TinyDTLS. I've added Bluesy in there as well because we leverage that for the platform. So as I showed you before with the SDK that ships on ARTIK modules, much of what's underneath that SDK are really these libraries or these projects. And so it's not just that the SDK stands alone, but really leverages the great work that's been done here. And then on the sort of what I call broker in air quotes level, we support Mosquitto. It actually ships on the ARTIK module. We've also done some porting efforts with Kura and Smart Home. And then Samsung is also part of the OCF, which basically defines IoTivity as another broker platform, what I would call. And then on the tools side, we've done some work with Arduino on supporting the Arduino open source standards, both on the software and hardware side. We, of course, work with Eclipse on tools for the IDE. So both Eclipse Che is a project that we've been working with, and also Eclipse CDT platform, because it's an embedded system. We've also done some quite a bit of work around Node-RED, the IBM project that allows you to do visual programming, and then a few other projects that we've been involved with, OpenCV, the ALSA libraries that let you do sound, and of course Platform IO, which is a great set of build tools for embedded systems. This is basically how we're leveraging open source for Samsung ARTIK. Some of the examples of that, and so I wanted to just add a few bullets of why we're doing this. Why should Samsung embrace open source? For one, really it helps drive open standards, and I think really having open standards benefits all the participants in those standards. So kind of a rising tide lifts all boats type of model. It also increases the developer adoption that you can get through reach. So not just Samsung telling folks this is a great thing, but everybody participating in that, saying, okay, PAHO is a great MQTT library. So that's what should be used. There's also an aspect of strength in numbers. So a larger developer base working on these projects, for example, basically produces more. And Samsung, as big as it is, really can't do it alone in that regard. It also provides some legitimacy to the approach that we're taking. So if we say, we're going to put XYZ technology on ARTIK, we'd like to get that right. And so how do you get that right? Well, by aligning with open source, you can really get some legitimacy that way. And then finally, I think it increases the scalability of the platform. And I mean that by the fact that most open source projects don't have a particular vendor in mind when they're producing the software, but really think about it in terms of scale and how it can plug into different types of vendors and different types of solutions. And I think that really helps overall the open source story for a commercial platform like ARTIK. So just in the last couple of minutes, I wanted to give some examples of some products that companies are using ARTIK for. So this one is kind of interesting. This is a company in Korea called Kong Monitoring, and they have a landslide detection system. And so they have all these poles, and if you've ever been to Korea, it's very hilly. And so it's a nice system for managing all kinds of information across the hillside, and they use ARTIK 5 for this particular solution with Zigbee. Real quick, a couple of others. Contact IO is also using ARTIK. This is a Bluetooth management, Bluetooth beacon management system. And then also Atonomics is another company that's using ARTIK. And it's a biomarker device, personal biomarker device for measuring things like cholesterol and minerals and inflammation and all kinds of things so you can make choices about your health. And then finally, Samsung actually is going to be using ARTIK in their connected air purifier, which is coming up soon. So yeah, so we got a win there. But But that's about it. That's Samsung ARTIK, how we're leveraging open source, and really appreciate the IoT working group efforts around that. By the way, we, in case it's not known, we did join the Eclipse Foundation not too long ago, just a few months ago, and so really proud to now be a member. So if you want any more information, artik.io, artik.cloud. And I don't know if I have time for questions, but...
Well, you're calling time for questions. While Kai, the next speaker,
I actually have a question.
Perfect.
I'm stealing my own time, so that's my guess. So most of the integration that you showed on the ARTIK Cloud are end consumer related, so from the smart home space like Philips Hue, Lifex, and Nest and whatever.
Yeah.
So how much is all your ARTIK business aligned with the Samsung smart home activities or smart things?
It's, I would say, somewhat aligned, but not exclusively. So we definitely have, you know, integrations with SmartThings because they're kind of a sister organization, and so you know we work well together with that. You know, we are going to be working more with Samsung devices directly, so you'll be seeing more. And I don't know if it will be called ARTIK Cloud or something else, but you will be seeing more of that type of integration with Samsung products. I think smart home is really one vertical that we're looking at, and it's an important vertical. But really, I think what gets very interesting is the industrial side of things and how, for example, can you have maybe refrigerator units that are like commercial refrigerator units in grocery stores, maybe on different levels of software that can talk to each other, you know, through a cloud mechanism. And so things like that, ARTIK Cloud, you know, might actually be an interesting choice for. Anything else? Yeah.
So if I just bought Samsung devices, could I imagine that in time their peer-to-peer connectivity would probably happen? And the value of that, of course, is that the house's bandwidth is now got clogged by every Samsung device not talking to a cloud.
Right, right. Yeah, and we see some of that. You know, there's trade-offs with device to device, device to gateway, device to cloud. And I think, you know, in some cases, you might want to have your, you know, television talk to your washing machine. Sounds strange, but you can imagine some use cases. Say you're watching television and you want to know when your laundry's done. You could, you know, have an interaction where your washing machine says, hey, you know, it's time to put your clothes in the dryer now, whatever. But yeah, I think you'll see some of that. You know, it's not so great user experience when you use your IoT device to turn on your lights and it takes 3 seconds, right? That's a long time to wait to get your lights to turn on. Probably want to keep the cloud out of it in that case.
I know there's other questions, but unfortunately we're running out of time.
Okay.
Daniel will be around all day.
I certainly will.
Okay, so thanks very much.
All right, thank you, everyone.